Welcome to aminacademy.com. In strength of material regarding columns, let us discuss about crippling load of the column when one end is fixed and other end is free. Look at the figure. Consider a column AB of length L and uniform cross-sectional area fixed at one end A and free at B. The free end will sway sideways when load is applied at free end and curvature in the length. L will be similar to that of the upper half of the column whose both ends are hinged. Let P is the crippling load at which the column just buckled. Due to the crippling load P, the column will deflect as shown in figure like. Now we will discuss further about the crippling load. Look at here, let Y equal deflection or lateral displacement. Y equal deflection or lateral displacement, and A equal to deflection at end. Deflection at section. Deflection at section, that is Y equal deflection at any section from distance x from the bottom, and A equal to full deflection. Deflection at end B. Deflection at free end. This is deflection at the free end. Now, moment, we know that moment equal EI d square y by dx square. Now, moment at section, moment at section due to crippling load. Moment at section due to crippling load. Equal P into A minus Y. Now equating both is 1 because both moments are equal, which is equal EI d square y by dx square equal P A minus Y, which is further equal PA minus PY. Now collecting EI d square y by dx square minus plus Py equal PA. Dividing throughout EI, we gives d square y by dx square plus P over EI y equal P over EI A. That means we are dividing throughout this by EI. Now, the solution of the differential equation. Solution of differential equation is y equal C1 cos x root of P over AI plus C2 sine of x into P over EI plus A. This is the solution for this equation where C1 and C2 are constant of integration, and the value of C1 and C2 are obtained from the boundary solutions. Boundary conditions we have. First one, look at here, for fixed end. For fixed end, look at here. Here, this is a fixed end is at A. By deflection y equals 0, fixed end at A deflection is 0, that is y equal to 0, and also slope equal to u of x equal to 0. There is no slope because it is a fixed end. Hence at A we can say at A when x equal to 0 and y equal to 0 we are having. Substituting these values x equal to 0, y equal to 0 in equation 2. Therefore, look at here. Here this is our equation. It will be 3 here. Equation 3. Now 0 equal, that is y equal to 0, C1 cos 0 plus C2 sin 0 plus A, which is equal to 0 equal cos 0 is 1, that is C1 into 1 is C1 plus sin 0 0, that is 0, that is therefore C1 equal 0 equal to C1 plus A, which gives C1 equal to minus A. At the point A, x equals 0, du by dx equal to slope is 0. Now, differentiating the equation 1, look at this equation, that is we have this equation, we'll differentiate this. First we'll write that equation first, y equal to, we'll write the differentiation equation, y equal, equation of diffraction we have, y equal to C1 cos of x square root of P over EI plus C2 sin of x square root of P by EI plus A. Differentiating with respect to x we have differentiation with respect to x, that is dy by dx equal C1 minus 1 cos is sine of x root of p over ei into root of p over ei. Then plus c2 cos sine differentiation is cos differentiation is minus sine, that is why we are having this minus, because of cos differentiation is minus sine, and cos c2 cos x p over ei into, because cos coefficient x coefficient is this, that will come, that is square root of p over ei. And a differentiation is 0 with respect to x. Now further we will discuss here dy by dx equal minus c1 is minus c1, minus 1 into c1 is minus c1 root of p over ei. In order we are writing sine of x square root of p over ei plus c2 p over ei cos of x square root of p over ei. Now these are the dy by dx equation here, but at the point A we know that x equal to 0 and dy by dx also 0. Look at this figure. At A, these are the condition, x equals 0 at A, as well as slope is 0. We are substituting that conditions here. Then it will give we are using these conditions here. Dy by dx is 0. Therefore, 0 equal minus c1 square root of p over ai. Then x is 0, sine 0, 0 the complete, and into 0 plus c2 square root of p over ei into cos 0 is 1. Therefore, we have c2 square root of p over ei equal 0. Because this complete 0, this is 0. This is the first condition. Now, from the above equation, it is clear that either c2 equal, either it is clear that either c2 equals 0. Therefore, we can say this condition c2 may be 0 either or square root of p over ei equal to 0. But the crippling load P, the value of p over square root of p over ei cannot be equal to 0. This cannot be 0. Therefore, this is either. Therefore, we can say, substituting these values, now c2 equal to 0 we are getting. Then substituting this values in, therefore c1 equal minus a. Because look at here, this from this equation we are getting c2 equal to 0. Therefore, only these conditions we have. Therefore, and c2 equal to 0, we are substituting these conditions in original equation. Therefore, y equal minus a cos x square root of p over ai plus a. This is the equation of deflection y equal minus a cos x the square root of p over ei plus a. And the free end. At the free end, then x equal to L, because full total length is of the column is L, and y equal to A. Look at this figure. At the free end, y equal to A, y equal to, at free end y equal to A and x equal to L. This x equal to complete length L. Now use that conditions. Use that conditions, we can get it now. A equal therefore that you can write A is alpha equal to A, that is minus A cos x is L p over ai plus alpha. Wherever a comes, let it's alpha here. Now from this, or you can use it, look at here, 0 equals minus a, that is alpha is 0 here, a cos L over root of p over ai plus a, no, plus alpha here. Therefore you can see both side alpha is there, so it cut. Therefore you can say it's 0 minus a cos minus a cos L over root of p over ai, or we can say a cos, because minus sign will go for equating 0. Then a cos L over L into p over ei square root equal 0. But a cannot be equal to 0. Therefore, you can say this equation, solution of this equation is cos of L square root of p over ei equal cos 0 is pi by 2, or second condition 3 pi by 2, third solution 5 pi by 2, like it's close. Taking the least practical value, the least practical value will take. For that we have L square root of p over ei equal pi by 2. From this we'll get by cross multiplying and squaring P equal pi square EI over 4L square. This is a crippling load for column, long column, for one end is fixed and the other end is free. So far we discussed the expression for the long column for crippling load at one end is fixed and other end is free. We have done. Please subscribe our YouTube channel.